Welcome to a video on ions in solution. Today we'll be discussing what happens to ionic compounds when they dissolve. I'm going to work through a series of 4 examples, but the main point of this video is that compounds are going to separate into ions. Ionic compounds, you'll remember, have no net charge. So when I write it, I don't write a charge. Whereas the ions in the solution, once they've separated, they do have a charge, and their individual charges remain present in the solution. Our first example will be adding sodium chloride, otherwise known as salt, into water. The sodium will split up into positive sodium ions and negative chloride ions. You can see here that because they both have a subscript of 1, I get 1 sodium ion for every 1 chloride ion. And even though the formula of the compound didn't have a charge, charges now appear on the individual ions. Example number 2 is magnesium chloride, which has a subscript of 2. This is going to change the number of chloride ions I draw in the solution. So here is the magnesium chloride dissolved. You can see that the ions split apart, but for every 1 magnesium ion, I have 2 chloride ions. That's because in the formula, there's a 2 subscript, and the 2 subscript tells me that there are 2 chlorides. The subscript only applies to the element it's right next to, unless it's outside of parentheses. I highly recommend that you draw this image in your notes. Now I'm going to give you a prompt to try. What would sodium oxide look like after dissolving? I've given you sodium and oxygen and their charges. You should draw them in the correct ratio. For every oxygen, how many sodiums should you draw? Hopefully your answer looks like this. For every 1 oxygen, you're going to have 2 sodiums because sodium had the 2 subscript. Alright, example number 3. We're going to take a look at how polyatomic ions dissolve. So here we have the example of sodium nitrate. I know that I have a polyatomic ion because after the metal sodium, the first capital letter, I see more than 1 nonmetal. So they need to be a polyatomic ion in order to form an ionic compound with the metal. That leaves us with the question, what happens to the polyatomic ion when it dissolves? And what happens is that the 2 ions, the metal ion and the polyatomic ion, split up when they dissolve, but the nonmetals inside the polyatomic ion stay together as 1 ion in solution. This is another graphic I would strongly suggest you write down. Okay, our last example is here. I'm going to pause in 2 places so that you can practice drawing ions in solution on your own. So in this example, we are going to work with calcium nitrate. First, I want you to decide what are the 2 ions present here and what are their charges. You may need to look this up. Hopefully you correctly split it up into the calcium ion and the nitrate ion. The calcium ion has a 2+ charge and the nitrate ion has a -1 charge, remembering that any polyatomic is going to be on your pink polyatomic reference table. Now you should draw them in on your notes. Decide how many calciums and how many nitrates you need to represent in this solution. Hopefully you remembered that 2 subscript and you have drawn in for every 1 calcium 2 nitrate ions. Also remembering that the N and the O and the 3 stay together. I don't need to draw them separately. So, what do ionic compounds do when they dissolve? First, we remember that compounds as a whole have no net charge, but their individual ions have a charge. So when they dissolve, they are going to separate, and those separate ions will have a charge. And the subscripts in the compound tell us the number of ions that would be present after those ions split apart. We do remember that polyatomic ions don't split apart. So NO3 stays together and becomes NO3- in the solution. Thank you for watching. Now you should do some practice on the left side of your notebook.